Here's two equations, each written in slope-intercept form. And when two or more equations are considered together, it is often called a system of equations. And our goal here is to see if there's a solution common to both equations. Well, if you did well with graphing, you probably can graph both of these in a short amount of time. We'll start with the one on the left. The y-intercept is 4, so we'll graph that on the y-axis. The slope is 2/3, so from the y-intercept, we'll go 2 up and 3 to the right and plot a second point. We connect the 2 points and we graph the first equation. For the second equation, let's remind ourselves that a subtract 7 is add -7, so the y-intercept is -7, so we'll graph that. The slope is -3. Remember that an integer can be written with a denominator of 1, so it's -3/1. We can put the negative with either the numerator or the denominator. I choose the denominator, so we go 3 up and 1 to the left. We plot a second point. We connect the 2 points, and we can see that these lines cross, and the point where they cross is a solution common to both equations. And since lines can only cross once, it happens to be the solution to both equations. And so we examine that point. We look for the coordinates, we do some counting on our grid, and we get -3 for y, 2 for x. We can substitute those values into each of the equations to make sure that they work. I've done so, they do. So -3, 2 is the solution to this system of equations. Here's another system of equations. They're not written in slope-intercept form, but perhaps we can use the x and the y-intercepts to graph these two equations. In the first equation, we're going to let x equal 0, and then 4 times 3 is 12, so y is 3, and we graph that point on the y-axis. If we let y be 0, then 3 times 4 is 12, and x is 4, and we graph that point on the x-axis. We connect the 2 points, and we've got a graph for the first equation. For the second equation, we're going to let x equal 0. Remember that subtract 8y is like adding -8y. So to make 48, we need a negative times a negative, so y is -6, and we graph that on the y-axis. And then, if we let y be 0, it doesn't take long to figure out that 3 times 16 is 48, but 16 won't fit on our grid. So one of our options is to get a larger grid. Another option is to remember standard form. In standard form, the slope is the opposite of a over b. In this equation, a is 3, b is -8. So we have the opposite of 3 over -8, or 3/8. A third option is to solve for y, which will then put the equation in slope-intercept form. I did not show my work this time, but there is the equation solved for y, and it confirms that the slope is 3/8. So from the y-intercept, I count 3 up and 8 to the right, and plot a second point, which in this case happens to land on our first line. So that point is the solution to this system of equations. Our final job is to read the coordinates for that point, and those coordinates are 8 for x and -3 for y, and that's the solution to this system of equations. And here's yet one more system. The equation on the left is a bit more complicated because of the parentheses. We're going to get rid of the graph, go to a clean sheet of paper here, and there's several things we could do with the first equation, but my choice is to divide both sides by 3. The 3's cancel. 12 divided by 3 is 4. We now have 2x plus 4y equals 4. We can find the intercepts again. If y is 0, x is 2. If x is 0, y is 1. We can also find the intercepts for the other equation. If y is 0, x is 12. And if x is 0, y is 6. So now we go back to our grid, and then we've looked up what we just wrote down for the first equation, and we graph the x-intercept 2, the y-intercept 1. We connect those two, and the first equation is graphed. For the second equation, we notice that the x-intercept is 12. It's off our grid, but not so far off that we can't figure out where it should be, and there it is, way over on the right. The y-intercept is 6. We plot both points, we connect them, and we can see that these lines are parallel, so there is no solution to this system of equations. These two lines never intersect. They have no common solution. Graphing is a good visual way to show common solutions of equations that form lines. It works well when the solutions are integers close to zero. It is also a good way to get approximate solutions when exact solutions are not required.